Go.
So today I've got some, I bought some new toys, and this is a battery monitor that was, I think, $8.95. And let's see, unfortunately my chat window went off the screen, so I can't get to the post button. How do I fix that? Well, anyway, here's the battery monitor. I'll get the link fixed when I get some time here. So basically, and this one's nice because you can tell it. You can tell you have lead acid batteries, or you can tell you have lithium batteries or something else, and then you can tell the number of cells, and it goes from like 10 volts up to 60 volts or something, and this stuff's all programmable. It's got the little barcode there, so it keeps track of keeps track of your charge, and you can actually program that. So you can say at 13 volts it's 100%, and at 10 volts it's 0%. So you can program all that. And they had another one that didn't let you do that. And then I also bought some of those sonar modules. So I've got a whole stack of those now. I'm thinking about using those little $3 ARM boards and put a bunch of these on one of those. So I just have a slave processor for sonar. And then the other stuff I've been playing with. Okay, I assume you can see that. So this was my experiment where I put two antennas on top of my car and used two of the Ublox M8T receivers and RTK Lab software. And down here below is a different piece of software poking through, but up here we have, so when you run the moving baseline, this says this is the angle. See, down here it lists the angle. If you look over here on this one, it's for yaw, it says 263, the angle. And I'm sitting in my driveway pointed west, so it should read 270 at this point. But you can see it says it's a float condition, not a fix. And this was one of the first tests that I ran. So I sat in the driveway and let it lock on, and it said pretty close to 270 degrees. So it was showing me that. And then so I sit in my driveway right here, and as I backed out into the street, it was still on a fix. And the thing was working pretty well. As I started driving forward, I got like halfway down the block, and the thing dropped back to a float, at which point it started fluttering back and forth. And you can see the numbers over here, the green line. This is basically good data, and then all of a sudden it drops into the float, and the things start bouncing around. And that's why I need to get the video working so I can show, I just start driving how that acts. And as I drove around the block, it got to one point it lost the signal completely here, or it didn't lose it completely. It dropped to a single point, which is bad when I'm running right here. And I don't know if that's trees or houses or what that is. So I came all the way around the block and came back and parked again. And then I let's see, what did I do next? So this one, I believe I switched to RTK mode. And one of the first things I noticed was, so I was in my driveway, backed out, and as I started driving around, it started tracking my position, but then it started doing this really goofy thing where it wasn't actually showing my path anymore. And I didn't think too much of it at the time. I was just playing with it, trying to get it to work. And when it was in RTK mode, it works a lot better. It's a lot smoother, and it doesn't seem to jump around as much. And then here's a case where I started off with it in a fixed mode, and it had a good lock, saying 270 degrees. I backed out of my driveway and went around the block this way. And this is like open space. As far as east and west, there's no houses. So both on the north and south, there's houses. And so you notice anytime I'm going north and south, it seems to have a problem locking on. And there's a place where I locked back on here, a place here. But in general, it didn't seem usable as far as trying to get the heading out of this by looking at this stuff. And then while I was at it, I fired up my new F9P receiver and just put it. So I was getting the RTK data. I was again in my driveway, backed out of the driveway, came around the block here, came back and parked again. And while I was doing that, over here where it says the GNSS fixed, occasionally I'd see that drop off to a float, but they don't change the color here, so you can't tell by looking at the color where it's dropping out. But just in general, it's working. It seems to give me a fairly decent result as I drive around. So then I came into work and was playing with it here, and this is the first run that I did. And again, this might be after I swapped my antennas. When I first did it and I was pointed north, it said 180 degrees. So I just swapped the two antennas, and then it says north. So if I'm sitting there pointed north, I got a nice vector saying that I'm pointed north. And it says my two antennas are about 1 meter apart. This is the distance between the two antennas here. And then over here again, it tells you your heading is 1.1 degrees, which is the same numbers they show down here. So I started here and I started driving around the building, and it stayed in fix. And every time I go around, there's a problem right here, because there's a building here, there's a building over here, and on all these plots you'll see there's a disruption right there. And as I come around the corner, there's problems over here. But in general, I came around, and part of the time was in fix, part of the time was in float, and it seemed to be more jumpy than it should have been. So then I tried some more settings, and then I got at this point where I could started off here pointing north, and I drove around, and again, so here's that point where I got a disruption there. I came around the corner and there's more disruptions there, but it stayed in fix all the way around. But when I was doing that, the thing was kind of jumping. I think especially when it does this stuff, the angle here flutters back and forth a lot when that happens. So then I did one more run, and here's another one that stayed in fix all the way around. Again, the same disruption here and same disruption here. And you can see down here where it turned yellow for a while. So for a while it went from fix back to float. So this was starting to look encouraging at this point. And again, I just got a point out back where I know coming around the parking lot, if I was parked at a certain point, that's north, and you can see the line is lined up north. So what happened was I came around and stopped, and I purposely drove to the point where that lined up to be north again. So it's not as though it's magically pointing north at that point. And see, it says 359 instead of 0, but that's, it's right ready to roll over again. So then this one, so then I switched to RTK mode. So I've got the two antennas on the top running on RTK, and it says, here's my distance between the antennas. And again, it says I'm pointing north. And the interesting thing was, now as I drove around the building, instead of showing the coming up all like this, the RTK is doing something goofy here. Just kind of wandering around on its own as I do that. So it's apparently when you're running RTK, it's not giving you telling you your actual position anymore. I think it's telling you the difference of position. So this is probably showing me error conditions coming out. I think if it was working right, it would probably stay right on that point, saying, your distance between the two and your offset between the two is staying right there. So this is something goofy. So as I drove around some more, this is the second run that I did. And you can see it stayed in, the whole time it stays green, which is good. That means it stayed in fix the whole time while I was in RTK. But it still would flutter around over here. And then I came around here, and I came around the building and came to a stop. And I noticed I was just sitting there, and the thing kept wandering here. Even though the angle stayed fixed, it seemed pretty stable. And now this point just kept wandering. I thought, well, that's odd. So I sit and watched it, and it wandered further. At this point, I thought, well, what happens if I turn 90 degrees? Is it gonna wander off in this direction, or is it gonna keep going the same way? So I did that, and it continues off in the same direction. So I don't know what that's trying to tell me at that point. So basically, I guess I could just ignore it. So if you notice here, see at this point, I was pointing in this direction at 232 degrees. And I guess between that one is where I changed, and now I rotated my car 90 degrees. So if you go subtract those, it comes out, I think it comes out to 100 and something degrees is what it actually is, because I wasn't being real exact. But the thing is that it keeps wandering off in the same direction, which had me kind of baffled. And I guess that's the end of that stuff. So also based on that, I have ordered a second F9P receiver. And that's supposed to show up on Monday, so I can then try to see if I can get moving baseline between two of the dual frequency receivers. And I want to see if I can get one of them to run RTK and give me a fixed position, and then use the second one to do moving baseline to give me heading. And if that works, that'll just be like a miracle. It's still more money than I should have spent on it. That's up to 400. That'll be up to almost $600 at that point by using cheap parts, but you would get an RTK fix And while that's moving, it'll give you velocity and heading. And then by using the moving baseline, it should give me an accurate heading, whether you're stopped or whether you're moving. So I'm going to have to play with that. And there was a guy on the Combine forum that says he has 2 receivers running a moving baseline, and I didn't see enough details. I was going to post another YouTube video where some random person on the internet says, here's my tractor driving using 2 F9P receivers in moving baseline, and he shows it as he's driving around in basically in a parking lot. He's showing that it's giving him a stable result. And then I looked into his grouping there, and he had another one saying, his initial thing saying he's got 2 receivers and one of those ESP type processors. So it's like an Arduino, but it's using that ESP processor, and that's how he's doing his moving baseline. So he gave a little description on that, but it's not clear. I don't think he's feeding it any correction data, so I don't know if anybody has tried the correction data on one and moving baseline on the second one to give you everything or not. So if I think about it, I'll try to track those down and post that too. So I need to go back here and figure out how to post this link now that I've got it. The problem is my post button is off the bottom of the screen, and I can't figure out how to get it back. Let's see. Anyway, so I'm done talking for the moment, and let's see. Anything else I have to say? Not that I fit. Oh, we talked to Novotel again yesterday. We had a meeting. They came in, and basically they've got a new field engineer, support engineer. So they're taking him around, introducing him to people. And again, he annoyed me by bragging about all the subscription stuff they have, and oh, that's our IP. We have to turn you on for this. We have to turn you on for that. And so it basically just annoyed me listening to all the stuff he was bragging about, how they're taking advantage of stuff. And every once in a while, you throw in something like, oh, well, we have good resolution, unlike Ublox. That's well, I'm pretty happy with my Ublox right at the moment. So anyway, that's just one more. Oh, another thing that came up in that, since Novotel doesn't use any kind of magnetic detection, they don't have any magnetometers in their stuff. And he says, oh, it's because you can't trust it on your vehicle. And he said you have to be careful, because if you put on a magnetometer on your tractor and you get it calibrated, and so it's working right, and then you put an implement on the back, so you put on a disc or a harrow or whatever, he says that screws up your magnetic, and you have to know, once you put that on, you have to go run calibration again. So I don't know if that's really true, or he was just pointing that out, that, well, you should buy our product because we don't use magnetic detection. So it's something to keep in mind, that if you put a sensor on your tractor, say if you put it on the back, like say on the roll bar on the back, yeah, possibly if you put something on, you hook something on the back to pull it, that might affect it. So you think, okay, I'll move the sensor to the front of the vehicle. But now if you put something on the front, like a front end loader or whatever, now you're gonna have a problem maybe with any of that stuff. So I don't know whether or not putting it up on a post is gonna solve that problem, or maybe put one in the front and one in the back, and then try to vote between which one is right. So that's something to keep in mind as you play with this stuff, to see if you notice that. Because I'd never heard that before, that adding something onto the back of your tractor is going to screw up something like that. So now that's all I had to say. So I'll go see if I can figure out how to post these links. I might have to sign out and come back on to get my screen back here, because as I move my screen up and down, it just will not come down far enough to show me that. Maybe if I do how do you do that? Gallery view. I might be able to play with my settings and get it back. Otherwise, I'll tell you what, I'll just log out and come back in, and then I'll have it. So I'll do that. So I'll be back shortly. So go talk about whatever you want.
Okay. I've made some improvements on the lawn tractor this week. I moved the gas tank down and installed electronic fuel pump and drilled holes for the ultrasonic sensors. So I'm getting ready to test your software sewing on a real vehicle. I'm going to be gone for a week, so hardware, I'm not going to have access to hardware.
Yeah. Oh, I plan to make some changes or add some things, and over the weekend, hopefully. So yeah, I hope by the time you have or you try it out, it's more mature, uh, the software.
Oh, I went to all that trouble. It turns out all I had to do was hit return. I don't have a post button, so I just typed it in and then hit return, and it works. So. Okay, I'll now go try to track down that YouTube thing. So
Hey,
when I find that, I'll post it.
hey Jeff, what's that $3 ARM board you're looking at using?
It's the one that's it's got the STM 4103 or something like that on it. I'll try to find that too and post that.
I was looking at using the Nano.
Well, one thing about these ARM boards, they're 3.3 volts, but they've got, as opposed to the little Arduinos, they've got lots of RAM. It's a lot faster. You know, it's like 72 megahertz or something. And the particular ones I'm thinking of, you have to buy a programmer separately, but it's like a $3 programmer. So you can buy like 2 of the boards and a programmer for $13 or something. And then you use the, I think you can get an Arduino IDE for it if you want to run Arduino stuff on it, but I don't recall right offhand.
And the I/O is another thing. I think on each of these boards for the sensor we'll have we'll need 2. So I think these come in under IC squared to your board, I2C, I mean. I would like to use the little Raspberry Pi for $10 because we could put ROS in there and it has Wi-Fi, so you can send that back into your main computer over just publish the topic.
Yeah, be careful with those Arduino, what's that one called? The Zero or whatever that is, because it's got weird connectors on it and you don't have USB coming out. So before you dive into it, look at all the details to decide if that's really going to do what you want to do without a lot of screwing around. If it matches what you want to do, that's great.
And so if we have 4 of these, so like you're going to have, I don't know how many ultrasonic sensors you're going to put on your board. And then is that I2C coming out for those sonars?
No, it's the thing where you've got a trigger pulse and an echo pulse. So you just need 2 bits. So it takes 2 bits per sonar. So of course I can't remember what the correct thing to type into search here, but I'll find it here. And the thing is, if you use, say, just an ARM board or an Arduino, you've got the option of how you want to connect it, whether you want to run asynchronous serial or I2C or SPI. And possibly on the ARM boards, which just have more peripherals built in, you basically have more options because they might have anywhere from 3 to 6 UARTs, and they might have 2 I2C and 2 SPI or something. The problem with that $3 board that I'm thinking of, if I can find it here, it's one of the first ones that came out, and it's got more peripherals than you have I/O pins. So as soon as you start assigning things, you start chewing up your capabilities real quick. But as long as you, again, know what you're doing, you know what you want it for, and you can pick and choose the parts you want for a $3 board, that works out great to do that.
And then would you go serial back into ROS?
I didn't get any of that.
I was wondering if you would you use serial to go back into ROS?
If I'm connecting directly to ROS, I probably would. I just plug in. Well, actually, that board, I think that board has a USB connector on it, but you have to load the software to talk to the USB. It's not like the Arduino where it just automatically works. But what I plan to do in most cases is take that little board and hook it to my big microcontroller board. So just either be direct asynchronous serial between the devices or I2C between the devices. And that brings up another point that I was looking at doing PWM to either do my steering and or to do my lighting control. And I remember Bob Hassett bought a board from Adafruit that does 16 channels of PWM, and it's controlled by an I2C interface. And I see Colin posted a link. If you search for PWM on our Slack channel, Colin posted a link to a website where a guy's talking about using that along with an Arduino and controlling RC servos. So he's controlling 4 RC servos at once with that, using the Adafruit libraries. And then I went and looked, because on Adafruit, they want $15 for the board. I looked on eBay, and they'll sell you a board for $5.75 with free shipping. So I ordered 2 of those, and they're supposed to show up early next week sometime. So that's kind of what got me onto the slave processor concept, that if I just put one of those boards with I2C onto my microcontroller, that gives me lots of PWM without chewing up my PWM channels. Because when I added my quadrature decode, that immediately chewed up. I lost 12 PWM channels by doing that.
Yep.
So basically, I was thinking maybe I'll use one of those to do my lighting control, where I'm going to have multiple LEDs, and that way I can run the brightness of each one up and down individually if I want to. And I could either take one channel there to run my steering, or put on a second board to give me another 16 channels of PWM to run RC servo type stuff. And that's where I was thinking, well, now I get the sonars, I'd just use a microcontroller board so I could have multiple, slaves out there doing whatever I need them to do. Well, I think that board is called like Blue something, Blue. Nothing's always turning up now, so I can't even remember what it was called. So if I find that, I'll post it either here or on Slack channel afterwards. What was the other thing? Oh, that let's see if I can find that PWM board. So go ahead, talk amongst yourselves here while I'm digging.
You're searching.
Usually you get quicker at finding stuff because you know what to type in. So that's not what I wanted.
So when have you been playing with your TX1 at all?
Not really. I put it out there. I've been playing with my Windows computer, trying to with WSL. So I was thinking maybe I can use that as my Linux computer and just use an SSH over it. And try. I'm playing with cross compile these days, so I'm gonna try that, because that one's an ARM processor, and I also have an AMD 64, which is a computer. It's an Intel i7, and I'm using an Intel i7 on my Windows computer. So I'm playing with those things. So I'm gonna try and use that in a few days. But yeah, I'm not doing much stuff with it. You can't just do stuff with just a computer. You need all the other bells and whistles. So slow and steady.
Yeah. I picked up a Jetson Nano. just going. I haven't got it set up yet, but that's planned for next week.
It's a great machine. It's so small. It's fantastic. I saw someone make a race car or something like that out of it, and it's just sitting on the top end, and it's really small. It was great to see it do that.
I'm hoping we can run our weed detection stuff on there.
Yeah, that's a good idea. It should be sufficient for sure.
I'm getting closer here.
The blue pill.
If I can find it here, I'll try to find one of the eBay listings where they'll sell you 2 of those boards with the programmer module for like $13. ARM.
That's a really good deal. I think, let me see. I don't have it. So I picked up a few of these. These are like $2 a piece. These are those nanos. But I think the ARM processor may be a better approach.
So here's one of the random links for. Let's see. So here's the you get 2 boards and you get this little programmer module, and then if you look around, you can find just the boards separately. So you can, and they come out to like $3 or $4. If you buy them from China, you can get them for like $2 a piece. And one problem with it is they say you have to go on the back. If you want to use the USB port, there's 2 resistors you have to either unsolder and replace, or they need a lower value. So you can just put on the top here, you can just put, let's see, stop moving on me. Where the USB pins come out on here, you can just put resistors in parallel to get the value you want. And up to this point, I don't think I've used the USB, or maybe I did just to prove that. I thought, well, it would be way too hard to do that to get the USB working, but I find a guy's tutorial on YouTube, and he says, well, type in this and this and this, and look, it works, and sure enough, it did. So I think I did have it working without replacing the resistors, but they say it's going to be much more reliable if you do that. So these have, I think before I said it was a Cortex M4, it's actually a Cortex M1, which is the first generation, and there are just millions of these things out there, but they're cheap and they're fairly easy to work with if you know about microcontrollers. And I think I was using the ST Micro development kit. It was what I was actually programming it with, and it works. They give you the one thing that comes up, and you can specify what peripherals you want and what pins you want them to be on. And then it says generate code, and it generates code that will compile immediately. And then you just go ahead and add to that whatever you want for, say if you want a UART, you go to your peripheral setup and you say, give me a UART, and it assigns the pins. And you just say, create the code, and you go over your code, and it says, put your code here. So you say, wait for a byte to show up, and then turn around and output it back to the port, and you're pretty much ready to go. So it's one more thing to learn, but you know, it's you got to decide if you can get a cheap board, you want to learn this.
And that's programmed in C or C++?
It's either C and or C++ for the ST Micro stuff. And I think you can get, if you look, I think you can get the Arduino IDE to talk to it also. And I don't know if you probably have to program in a bootloader first, or maybe you have to go through a little programming module to get it on there. So there's some way, if you program an IDE, there's some way to do that. In fact, I think that's what you do is you put on the programmer module, you download the bootloader to it, and then you just connect it to it with your Arduino IDE, and you have to add the extension for ARM 103 or whatever, and then I think it'll work.
That's interesting. I like the idea of those daughter boards maybe expanding out.
I'm sitting here looking at this. I don't see a voltage regulator on that board, so it could be you have to run it on 3.3 volts. You have to supply. You can't just hook it up to whatever like you do in Arduino. So that might be something else to consider. Was there anything else I said I was going to post?
You covered a lot.
So I don't know if I have anything else to add right now other than, as I said, I was thinking about doing the slave processors, and so now it's down to a point. Do I create an I2C bus and have all the processors talk to that, or do I create a single asynchronous serial bus that I can daisy chain things on that? That'd be another way to do it. So it's just a matter of sitting down, whatever's the most convenient at the time, hook it together with jumper wires and try it. And if that works, great, and if not, try something different. So.
Yep.
I was thinking I had some other stuff on order too, but I can't remember what it was. Get the GPS module should show up Monday. Oh, those PWM boards will show up on Tuesday, and I got my parts today. So maybe that's everything that was on order.
That's great. So right now the goal is to use these boards and connect into your steering control and your velocity control, your motors.
Well, actually, my big microcontroller already talks to the big motor drive to give me velocity, and that connects to. It's just that board connected to a Cytron board, which connects to my motor, and then I've got the encoder feedback, which I haven't actually implemented, but the encoder works. So it's just a matter of figure out how many counts per second is the speed that you want, and then I can just do a feedback loop saying, if your current speed does not match the requested speed, either run the speed up or down. So that pretty much is taken care of. It's just that I'm too lazy to go in and create the PWM channel to run the servo on this thing. And that the other problem is since I've chewed up so many PWM channels, I think I've got some left over because there's 4 LEDs on the board that I think are tied to PWM channels. So basically I can just put a jumper on in parallel with one of those, and just my LED will go up and down in brightness as it runs, but that should be a way to do it. So it'd just be a matter of figuring out, because if I do it, I'll have to pick a timer channel and then initialize that, and they either come in 16-bit mode or 32-bit mode, and the 16 would be fine. Then you have to pick a clock source and pick a prescaler, and then put in the value to generate your PWM. So it's a couple hours of screwing around probably. But I thought, well, if I get this other board, that might be a better way to go, because then I have a whole bank of RC controllers, or you can use the channel. You should be able to mix and match. So one could be an RC with a 1 to 2 millisecond pulse width, and the channel next to it could go 0 to 100% for running LEDs or motor speed or whatever you want. So that might work out well.
Wow, it's good progress. I was telling someone when you were rebooting, I've got the gas tank moved down and added the electric fuel pump, and so I tore the tractor down and put it back together. It's out running around. But I'm going to be gone for a week, so I'll lose access to hardware. So now just work on software. What's nice is you can record ROS bags, and so you can feed data in and then play around with stuff. So
if I was going to be gone for a week, I'd probably do nothing. I'd probably just kick back.
No way. I'm going to meet you guys up at Purdue. I want to have a driving robot.
Oh, you're going to that, okay.
Are you going? You're going.
I don't know. It's such a long ways off. What is it, 2 weeks or something? Or, I don't remember what it is.
16th, 17th, 18th. The competition's 17th and 18th, but I didn't know how long of a drive it is.
It would be a fairly long drive for me, I think. I think it's from here to Chicago, it's like 8 hours, and then from Chicago over to there is another hike. So I don't know how long that is, but
That's 2 hours.
it's only 2 hours from there?
From Chicago, it's 2 hours.
Okay. No, I still might consider it. I'll have to see what's going on here.
You can get a flight.
Yeah, I suppose it could.
Indianapolis,
Yeah. It's just 1 hour from Indianapolis.
$100 each way. Maybe cheaper than fuel.
Probably is, yeah. I guess that's all I got.
All right.
Hey Matt, if you can share pictures of how you moved your the gas tank, that would be cool.
Okay.
Do you still have your IMU bolted inside of your control box, or did you mount that externally somewhere?
No, inside.
Have you tried running any calibration, like say driving a vehicle type thing?
No, but I was great. So I tried to do a calibration with, anyway, so I have a teensy board that I can plug into the IMU, and then you can actually run the calibration right from the command line. So I just plug this into the Raspberry Pi, plug this into the IMU, and then I can drive around and do the warm start calibration, which is nice because the other one, the Razer IMU, you have to have processing running and some other stuff. So you have to put a laptop on your machine and then try to get all that working. But I thought the ability to run it from the command line is really nice. But I haven't done that yet.
So what's this concept of a warm start calibration? Is that the one that it reloads previously stored values, or is this it creates new values?
Exactly. So somehow it has memory on that little IMU board, and then you store those values on there. And then when it starts, it tries to calibrate itself. But if you've already calibrated it, it'll pull those values out and then use those to start from. And so it's supposed to get you a closer or a faster approximation.
And do you think it's going to be smart enough that if I thought somewhere the calibration routine said it's going to pick 100 points or something, it's going to run for 100 points. So I'm wondering if you are on flat ground, you just simply drive around in a circle, or some people said driving a figure 8, that without doing the extra roll and pitch, you're just doing basically doing the yaw. Then as you do that, once it times out with 100 points, it'll say, okay, here's my result from that. So that might work, but I personally haven't tried that.
Yeah, I definitely like the figure 8. And then when you start the calibration on this board, it will say 0, like I can't remember the name, but it's just like calibration status or something will show 0, and then you just drive around till it shows an 8, and then you can hit save.
Have you looked at that calibration routine hard enough? Could you just move that over to the Raspberry Pi so you've got them both on the same controller, or have you not looked at that?
I have not looked at that enough. I don't. That would be interesting. So you could do when you initialize your robot, you could do a calibration or something. I tried to hook both the Raspberry Pi and the Teensy to the IMU, so I could do either one while it's on the robot, but that didn't work out.
Huh.
But running a calibration directly from the Raspberry Pi would be kind of cool. Like run a calibration routine. It's a good idea.
I didn't look at the code to see what they're actually doing in that. So, and on mine, I was going to put my sensor onto a Teensy and both calibrate it and read it by using the Teensy and not use a Raspberry Pi. Because at this point, I haven't decided to put a Raspberry Pi on at all. But maybe I could. There's no reason why I can't do that.
Well, that's a good point, because you could use platform.io, and then load, well, you'd lose control. Yeah. You'd have to somehow, I don't know how you would switch between the calibration on the teensy, because it kind of has you flash the teensy with that. You'd have to put that in there somehow to be able to switch. But if you were reading the IMU from the teensy, that would be cool. Probably a better way.
Let me put a note here. ND EM 7180 IMU. So I just stuck a note in there that we're talking about that. So
go back to it. I know that's something that Will was asking about, is reading or getting a ROS node from an Arduino or from a teensy out from that. That shouldn't be too bad. I haven't done that work yet though.
So again, I'm done talking yet again. So
okay. So, and anything else for today's?
No, I don't have anything.
All right. Well, I hope you guys have a great weekend.
You too. Thanks.
okay, see ya.
Bye.